These are still non-linear, and U-substitution I'm just going to show you that it's endless the way they can put these things together. This is just a bit of a twist. Okay. Generally we want to get rid of the complex part of the function of the integrand. So let's just set, and when you see it you go, oh my gosh, okay, that's not that hard. U equals 2. So du dx will be 1. Let's get that dx to the other side, and I guess they can go. So we're going to get u to the 4 du, but this x is a bit of a problem. Can you see that x? It's the same x. So we can see that x equals u minus 2. So that x equals u minus 2. I'm glad I left myself enough room there, but you can see that, I think. Clearly, this is actually doable in methods in the other class. We would just expand that bracket, expand the x and get a whopping big polynomial and integrate, no problem. But if that was to the power 7, it just becomes a bit more tedious. Whereas here, when I expand my bracket, I'm just going in there, I'm going to get the integral of u to the 5 plus, minus 2u to the 4, and then du, u to the 5 is u to the 6 on 6, u to the 5 on 5. What was u? X plus 2. On 5 plus c. Can you imagine expanding that baby and then getting an answer and having to factorise it? No, thank you. We wanted to use U-substitution. That's nearly that pattern for the natural logarithm, but it's not, because x is not the integral of 5x plus 1. But again, we want to simplify this more complex part of the integrand, so set and we'll get that dx to the other side, get rid of that. Okay, so let's just fiddle. So I definitely want a 5 in there, so that means I've got to put a 5 out there. That looks all right. That's about all we need to do. The 5x plus 1 is just going to be u. The 5 dx is going to be du. And this x is left over, but that's that x there. So x will be u minus 1 on 5. So that x is typical of leaving myself not enough room. Merge those denominators. U on 5u, that's du. Let's split this up, minus the integral of 1 on 5u. We want that 5 out front, don't we? Those u's are going to cancel. That 1 on 5 is to the whole thing, isn't it? Because the 1 on 5 is to the whole thing. Okay, the integral of 1 on 5 is just going to be u on 5 minus 1 on 5 log u. And what was u? I've forgotten already. 5x plus 1. 1/5 outside a big bracket 5x plus 1 on 5 minus log 5x plus 1 on 5. Look at these 5s here. Let's just get them out and make that a 25. That just neatens up that factorising a little bit. Okay. There we have it. This is another one that you just need to see without really, just through practice. Set u equal to root x. If you don't already see it, you're going to have to go u equals x to the half and follow your nose here. Chain rule and all of that. But the derivative is, hopefully you know that by now, we're going to get that dx to the other side. And you can see, there we go. That's what we're chasing. So the thing that's not there is the 2. So when we rearrange this integral, we need to put a 2 there. There needs to be a 2. So if a 2 goes down the bottom, a 2's got to go out the front. Now we have the whole substitution there for the du. Okay, equals 2 the integral of sine u du, which is 2. What's the integral of sine u? And what was u? What was u? Root x plus c. Is that it? Is that it? We've got another one. Love them. Another one. So generally speaking, what we've been doing is setting u equal to the 3x, or the subject of the trig or whatever we're looking at. Different. So you've got to do all of these questions so you're right in the test. I hope you're okay that it's just 1 on x. If not, do that by using the chain rule. And we're going to get this dx. Again, we've got the same extra 2 there, but you can see how it's coming together. Let's rearrange that integral. Natural log of 3x on 2x dx. And this time we need to get rid of the 2, so I'm going to just take it out the front so that we're left with that. We've set the whole of natural log of x to u, so that's going to be u, and 1 on x dx is du. That's the simplest integral ever, which is u squared on 2. What was u? Natural log of 3x. So it's the natural log of 3x all squared on 4 plus c. So you can see they're not actually all that hard, but there's so many different ways of putting them together. So please make sure you do all of these, all of the textbook questions, and you'll be right for the test.